In this video, we'll show how and why consumer surplus is area between price line and demand curve, and producer surplus is area between price line and supply curve. Both curves are linear. In the next video, we'll study nonlinear curves. We'll use Mathematica. Define demand curve. As price and quantity are inversely related, therefore beta 1 must be negative. We assume here beta 1 is minus 0.15. Intercept. Alpha 1 is 42. Define the same in Mathematica.
Define supply curve. As price and quantity are positively related, therefore beta 2 must be positive. We assume here beta 2 is 0.25. Intercept. Alpha 2 is 25. Define the same in Mathematica. In equilibrium, set the demand and supply equal. And solve for the equilibrium market quantity. It is 42.5. Put the equilibrium quantity either in the demand or supply equation and solve for equilibrium market price. It is 35.63.
Let's show it graphically. Plot the demand curve. Plot the supply curve. Define dotted lines. Show intersection of two curves and resulting equilibrium price and quantity. Price is 35.63 and quantity 42.5. Notice that along the demand curve towards left, consumer is willing to pay more than the equilibrium price. Therefore, area, in monetary terms, under the demand curve and above the market price line is consumer surplus. Likewise, along the supply curve towards left, producer is willing to sell at prices less than the equilibrium price. Therefore, area, in monetary terms, above the supply curve and below the market price line is producer surplus.
Underlying principle in case of consumer surplus is diminishing marginal utility. Each additional unit provides less satisfaction to consumers. Underlying principle in case of producer surplus is increasing marginal cost. Producing additional units becomes more costly due to diminishing returns. Plot shaded area for consumer surplus. Show with previous diagram. Plot shaded area for producer surplus. Show with previous diagram. Here we show both shaded areas and market equilibrium at the intersection of demand and supply curves.
Using calculus and mathematical economics, we show consumer surplus as shown here. This is integration of demand function, showing area under the demand curve, vertically between demand curve and x-axis, and horizontally between y-axis and intersection of demand and supply curve. This is whole area of integration. This area subtracted from the previous area. It is rectangular area, showing expenditure. This rectangular area, shown by dotted lines, is subtracted, leaving us with this triangular area, the consumer surplus. Here, we input this formula into Mathematica, giving us $135,460 as consumer surplus. This is Mathematica list showing us 3 calculations. First element is the integration part, which is whole area under the demand curve. Second element is area of the expenditure rectangle. And the third element is difference between the two, giving us triangular area, which is consumer surplus.
We can double-check through area formulae of geometrical shapes. Define rectangle area, which is product of its two sides, equilibrium quantity, and equilibrium price. For area of the triangle, input triangle base, that is equilibrium quantity. Triangle. Height is the difference of demand curve intercept and equilibrium price. So, the triangle area is half of triangle base times triangle height, and it double-checks the consumer surplus value calculated by integration earlier. This double check by geometrical shapes is not available in case of nonlinear curves, as we'll see in the next video. Area under the curve, calculated by integration of demand curve over the desired part, is equal to the triangle area plus rectangle area, which Mathematica tells is true. So the consumer surplus is equal to area under the curve minus area of the rectangle, which again is true.
Now, let's turn to producer surplus. Using calculus in mathematical economics, we show producer surplus as shown here. This is rectangular area showing expenditure. This is integration of supply function showing area under the supply curve, vertically, between supply curve and x-axis, and horizontally between y-axis and intersection of demand and supply curve. The result is producer surplus, the area above the supply curve and below the market price line. The value is 225.78. This piece of Mathematica code puts shade in producer surplus area. It has random color function. Every time you hit return on keyboard, color changes. This is Mathematica list showing us three calculations. First element is area of the expenditure rectangle. Second element is the integration part, which is area under the supply curve. And the third element is difference between the two, giving us triangular area, which is producer surplus.
We can double-check through area formulae of geometrical shapes. Producer surplus is area of triangle right above supply curve. For area of the triangle, note that one side of it is equilibrium quantity. Length of the other side is the difference of supply curve intercept and equilibrium price. Note that intercept of supply curve is 25. So the triangle area is half of the product of its sides. The area is 225.78, which is producer surplus. In case of nonlinear demand and supply curves, as we'll see in the next video, we would not have so-called ready-made geometric shapes for which area formulae are available. Another way to find producer surplus is to subtract this trapezoid area from the rectangle area. This is the formula for the area of a trapezoid. One side is 25, the intercept of the supply curve. The other side is equilibrium price. The distance between two sides is equilibrium quantity. This is trapezoid area. When we subtract it from rectangle area, the result is producer surplus, as confirmed here.